Welcome to the Free Library of Philadelphia. I'm Andy Cahan, Director of Author Events, and I am very excited about tonight. Considered one of the world's leading forest ecologists, Dr. Suzanne Simard is most famous for revolutionizing our understanding of how trees communicate with each other. She and her team discovered that complex systems move water and nutrients between the trees in social networks that are in some ways much like our own. A professor of forest ecology in the University of British Columbia's Faculty of Forestry, Simard has shared her research in both academic and popular forums, including 3 TED Talks and 2 documentary appearances. And I understand there may be more films in the offing. In her best-selling book, Finding the Mother Tree, she guides us into the intimate world of trees, not only through her observations and data, but also through the beautifully told story of her upbringing in the logging rainforests of British Columbia and her unique, clear-eyed perception and poetic vision of these mysterious beings. Tonight, she'll be in conversation with Joan Maloof, Professor Emerita at Salisbury University and founder of the Old Growth Forest Network. Some of you may remember her from our event with Richard Powers for the Overstory. Her most recent book is Treepedia, a brief compendium of arboreal lore. Suzanne, Joan, thank you for joining us. The screen is yours.
Hi, Suzanne.
Hi, Joan.
Good evening.
Good evening. It's so nice to be here with you.
Thank you. I loved your book,
Thank you.
Of course. And one of the things that I loved about it was how you included the personal stories. It wasn't just the science of the forest, although that's fascinating. It was also the stories about your life. And I know your life now has taken an interesting kind of turn. You're practically a movie star in all these documentaries and in the papers and magazines. And I'm just wondering, as a former professor myself, how you're able to weave that professorship life with your new life as an author and a spokesperson for the forest.
Well, the book just came out, and because we're in a pandemic, I haven't been mingling in the halls of my university for a while. So I don't know as an author and a professor, other than that my colleagues seem to like the book, which is very good and nice. And prior to that, it was like, it didn't really affect my professorship that much, the documentary films and my work. I'm standing among giants, I always say, and we're all devoted to the forest and doing the best we can. And yeah, it's a good place to be.
Yeah. So do you still have graduate students that you advise right now?
I do. Yeah, I do. I have, and I have a few more starting up, and most of them are working in what I call the Mother Tree Project. And we're trying to find ways to save old trees while still being able to get some, products out of the forest, but also just trying to understand what the effect of different ways of taking out trees has on the ecosystem, the carbon, the biodiversity, the water, the air, so we're trying to really study that very closely. And of course, the students are all engaged and they're wonderful, and they're basically the leaders of the project.
Nice. And at the end of your book, you talked about the Mother Tree Project, and it sounded like you were inviting the readers to be part of the research. How would that work?
Yeah, well, I am, because the project, my vision for this project is to provide a place where people can go and be in the forest, feel like they belong, and to have agency in what we're doing and how to conserve forests. And so that was one of my goals. And the other goal is, because I always say it's a 100-year project. It's actually more than 100 years. And of course, I'm 60 years old. So it's going to, continue on after I'm gone. And that is also one of my goals. And so the students and the people who come to look after that project in the future generations, this is for them. And so that's my invitation, anybody who wants to join. And then they also I would like, or I encourage people to try and do similar things in their own forest, because I'm working in a particular forest type, the Douglas fir forest, but these principles are similar in other kinds of forests, but of course every forest is unique and local, and so trying different ways to engage with the forest and get the things we need from it, but not too much, is something that I think that everybody can try, and so it can serve as sort of like a learning experience for people to take it elsewhere in the world.
Yeah, that's beautiful. So you and I are both involved in projects that we think will go on beyond our lifetimes, because the forests have a different time scale than we have.
Yeah.
So to really be effective with them, we need to not just think in a limited way.
Yeah, and as you know, Joan, like trees are long-lived creatures, right? They can live. I mean, the oldest trees in the world are 5,000 years old. The bristlecone pines in the Southwest U.S. and yeah, they're on a different time scale. And then a forest is so much bigger than most things that we study. It can be over, many, many, many hectares, hundreds of hectares. And so the scale is so different. And that means that it's more than one life. It's more than one lifetime that needs to see these experiments through to the whatever culmination it might be.
Mm-hmm. Mm-hmm. Yeah, so big, so fascinating, but we have to just grasp it somewhere and try to understand what we can. And I think I wanted to ask you too about the earlier part of your life. I know you were involved in forestry with your family, and then when you were going to college, you said, well, what should I study? Well, I love spending time in the forests. I'm going to study forestry. And I think a lot of young people feel that call. They love forests, they want to study forestry, but then they realize that this studying of forestry is leading to them maybe marking old growth forests for cutting, as you have done. And I was wondering if you could talk about that a little bit, or share any advice you would have for those young folks.
That's such a great question, Joan. You know, yeah, students come into forestry and most environmental sciences because they love the forest, they love the oceans, they love the water, they want to save the whales and save the old growth forests, and that's great, and they should. And then, they come and then we teach them all these wonderful things about forest ecology. And then in the latter part of their degrees, at least in the Faculty of Forestry where I'm at, it's, well, how do you cut down the forest? And so I think they feel a bit of betrayal in a sense, and a little bit of a, head spin. And then we say, okay, go to it, right? And then they get out in the world, in the industry or government or NGOs, and they're faced with, all these contradictions, all this, heartbreaking, exploitation of forests. And, how do we help these students navigate their way? I don't have an answer to your question, Joan. I think that every student struggles with this and has to find their own way. And we support them. And I think too, in a way forward, what I would, I think, okay, so here's my hopeful lesson is that we have, like, forests need people, right? People have always lived in forests. Forests cover a third of the land area. People have been here for thousands of years, and forests even longer. And we've been a shaping force and agents in the forest for as long as we've been around. And I think it's important for students to know that it's not all a negative thing. It can be very positive. And that looking after the forest takes a lot of skill and a lot of observation. And what we want to train people is to be, keepers and protectors and stewards of the forest, not just exploiters or not exploiters, and to create a craft. It can be a craft. It can be a beautiful thing to do. That's what my grandfather did. He was a horse logger, and he selectively cut trees, and it was a real craft for him. It was a real vocation of love for him.
Yeah, that's beautiful. Now, do you think any forest should be completely left alone by humans? Do you think we should have some controls where we can compare
For
what we've
sure.
done?
Yeah. Yeah. Yes, for sure. I mean, I think that, I mean, for one, we do need those. Of course, anything that you study or any experiments need control so that you can understand how things are changing. Um, but also we need these reservoirs for biodiversity and for carbon storage, and you know, even though they are always being affected by humans as well. I mean, global change is a human caused thing, and so all forests everywhere around the world is affected by that. But more and more now we need, I would say, you know, the forests need our help in multiple ways, and one is leaving them alone to do their amazing work of storing carbon and housing biodiversity and cleaning our air and water, even knowing that we always will have an impact on them, you know, because of our global environment. But also, you know, that the forests need help in other ways too, in that that as they're under climatic stress, you know, it's gotten to the point now where it is our job to help these forests stay healthy, be able to adapt to this changing climate, which is changing so rapidly that there's no way they'll be able to adapt as quickly or migrate as quickly based on historical rates of change. And so really our role, I think, as people is becoming, you know, even more crucial in a lot of ways. So yeah, conservation of old growth forests and leaving them alone is crucial, but also in the rest of the forests, we have an important role to make to help keep these forests healthy.
So we have to do both at the same
Yeah.
time. And I noticed in speaking of the older forests, British Columbia, where you live, has some of the most beautiful old forests on the planet, the most carbon dense forests. And some of them are still being cut right now. And it's heartbreaking, and it's causing a lot of outcry that these last forests should be saved. I'm hoping that you might be able to talk to our audience about that.
Yes, yeah. So you're right. Like all along the Pacific West Coast, from the redwoods in California all the way up to Alaska, these have been identified by many researchers, including Dr. Beverly Law at Oregon State University. She came out with a recent paper just really showing how important these particular forests are for carbon storage, the carbon stocks that they have, and the biodiversity. And these things are correlated. And she said rightfully that these forests need to be saved, right? That they're way more valuable standing than cutting them down. You know, and really in Canada, we won't ever be able to meet our carbon commitments, our biodiversity commitments to the United Nations if we cut these forests down. And yet, you're right, here we are cutting them down. And it's really upsetting for everybody, including me. In fact, you know, in British Columbia, these really productive old growth, those iconic West Coast forests, there's only 3% of them left in British Columbia. Vancouver Island, where what you're referring to is the Fairy Creek blockade, only 1% of those forests are left. And here they are cutting, you know, planning to cut the headwaters. And I think that people, you know, we've been misled. And I would say, and continuing to mislead, the government continues to manipulate the numbers to work in their favor. Industry, of course, wants to cut them down. But even more so than that, over many generations in the past, the plan was laid out that we were going to cut down all these old growth forests, right? If they made an allowable annual cut and they're just following through, and that's what, you know, but we didn't have a say in that, did we? Most people had no idea. And so we were kind of like in this catch-22 situation that we're in this, you know, the promises were made, that the licenses were given to the companies, and now in order to save them, we kind of have to buy them back. And it's, you know, and yeah, it's a real tragedy in so many ways. But
so much else has changed since then. Like we just understand so much more about the forest. I mean, from your work, the mycorrhizae, the carbon, the biodiversity. So we should be able to be flexible and change.
We should,
but it seems like that the industry and the governments are having a hard time with that change.
Yeah, I know they're so, it gets so entrenched, right? And I think that, you know, the infrastructure gets put in place and the licenses get put out, and then to change that course takes a lot of courage. and a lot of fighting
Mhm.
and maybe some payments, but it's worth it, right? Like, I think we got to keep pushing them to be flexible so that we can save these things. And the easiest fallback for them is the status quo always, and that's always what they're going to default to. And so any kind of change, it's got to be people on the ground, people doing with their voices, people demonstrating, people protesting it. We have to do this stuff in order to make these changes happen.
Mhm. And if you feel like me, I mean, I'm proud to do that, even if I think it's not going to make much of a difference in one particular case. I still feel like to use our voices and to use our hearts for the forest just feels good.
Yeah.
Do you find yourself getting more and more of an advocacy as you go along?
Yeah, so I'm 60 years old, right? And earlier in my career was just, I mean, I always had that feeling of horror when I was working in the forest industry, and concern and worry, and trying to make change. But also, very vulnerable as a young woman in a male dominated field, and, easily criticized, and was heavily criticized. And I had a lot of fear. But now that I'm older, and my research is well established, yes, I'm becoming more of an advocate. But of course, scientists draw a line at some point and say, either you're an advocate or you're a scientist. You can't be both. And I kind of disagree. I think that that's kind of hiding. It's hiding. It's not using your knowledge to its fullest extent. And I think we see more scientists doing that. James Hansen was a really great example with climate change. He just said, enough already, got to say something. And so I feel like I'm one of those people, and I'm continuing to have graduate students. I'm continuing to be a professor, but I'm also supporting the protesters at Fairy Creek.
Yeah. Wow.
Yeah.
Good for you. How are you supporting them?
Well, I'm doing all kinds of interviews. So this morning, for example, I was up at 5 or 6 o'clock talking on the CBC radio, Canadian Broadcasting Corporation, which is like NPR, talking about Fairy Creek, and then another interview with CBC Morning Edition talking about Fairy Creek and old growth forest. So I'm doing that part, right? I'm not on the front lines because I can't do all of that, but I'm doing what I can.
Yeah. Excellent.
Yeah.
You're talking about that line. I went to a scientific presentation one time, and it was about insecticides and how they're affecting biodiversity. And the presenter at one point put up a slide with just a red line down it. And he says, here's the line, and now I'm going to cross it. We should not be using these things. So yeah, I think more and more scientists, we have to be able to use what we learn.
Yeah. Yeah. And, I don't know, we could have this thing is coming to my mind, that, we know a lot, right? And we know how to do things better. And we have so much good science that's not being used, it's being ignored. And so how do you get that? It doesn't do any good to sit in a library or in a journal. If it never gets used, it does, I guess it builds that somebody else can use it, but we're at this crisis point with climate change that we have to act. We don't have that much time left. At the same time, these are systems, these are complex systems. The beautiful thing about forests is that if we can get on the right track, they can change pretty rapidly and recover for a good part of it. And so that, that's really hopeful. And that's why we keep pushing, because we owe it to our next generations to do that.
Yes. Yeah. That's what I see where I live. So 99% here of the original forests have been cut, and now they've regrown, and now we're getting ready to cut them again. And that's what we're trying to stop. So not the original forest being cut or the old growth, but the second growth, and saying, wait, let's preserve some of these, let them get older, let them heal. They can heal if we give them enough time, but if we keep cutting over and over again, then eventually they won't be able to.
Yeah, it drains them, right? Well, you know, in the Mother Tree Project, we're finding that, you know, clear cutting a forest, you lose, like right off the bat, you lose half the carbon, right? The above ground part is turned into toilet paper or pulp, or maybe you know, a portion goes into long-term products. But I think it was Bevla who did these modeling studies and said, you know, 65% is basically just gone immediately into the atmosphere, and it takes, you know, centuries to get that back, and we don't have centuries. We have maybe a few decades, maybe not even, you know, we got to act now. And so as much as we can conserve these forests and not cut them now, the better off we're going to be. And even if they do cut, what we found is that partial retention, like retaining the old mother trees, the old trees, is really, really important. That can actually mitigate a lot of the losses, you know, the losses of biodiversity and the losses of carbon. There are ways to do this that doesn't have to destroy the forest. In fact, like the Menominee in Wisconsin, right? I haven't been to those forests, but I've heard that they are able to continue harvesting their forests while even increasing the yield and the productivity, and it can be done. And that's why we need more people, right? More foresters, more students, more learners.
Exactly. Yeah, the Menominee Forest was a dream to me. I thought, we can have these beautiful growth forests that are intact, but I went there and it was different than I expected. It's definitely a working forest, but they are doing it more gently than the other foresters are doing.
Yeah.
Well, it's so wonderful to talk to you about this. And I also wanted to say what makes your work so special and your book so special is the science behind it, that at some point you learned how to design and carry out good experiments, and you had this inquiring mind. You weren't just going to help to cut the forest down. You're not just going to speak against cutting the forest down, but you want to learn about it, and you do that through designing these experiments, the science, right?
Yeah. And yeah, so I mean, it was definitely a learning process, like how to design an experiment, especially a meaningful forest experiment. It's got to be big enough, it's got to be long enough. You need to observe things and watch variability over years to understand what's going on. So, you know, these forest experiments are not simple, but at the same time, you know, you can do a lot of smaller experiments to help you understand the mechanisms that are underlying these longer term effects. And so it's, you know, it's a nested approach to try to, you know, try to project what is going to happen in the future based on the mechanisms we understand. So yeah, I've had to learn many different things, and actually I would characterize myself as a survivalist more than anything, because I had to survive in that environment, right? And continuing to be able to inquire and find things out while, you know, while being, you know, under critique and not having enough resources, and, you know, trying to do many things in my life, like being a mother at the same time. Like, it's challenging, and so that's why I say I was a survivalist. And
isn't it amazing when you look at your life now? Like, who could have predicted you're this movie star, practically, this spokeswoman for the forest, you know, very famous, best-selling book. I mean, isn't
who would have thought? I would never have thought that.
The trees are doing this.
Well, so, it is about the trees, but it's also about humans and trees and science, and that science is such a human thing. And we've had science even before Western science, right? Indigenous science has been here, you know, for thousands of years, observing variability, you know, trying things, testing things. You know, it's a natural thing that we do. And we got to keep doing it, and we got to keep adapting and changing, and finding more out about the stressors of climate change, for example. What a devastating and yet fascinating phenomenon. You know, keeps us scientists going for a long time, but it's also, you know, it's heartbreaking too.
Yeah, the change, what we're doing, and hopefully we're waking up. So thank you so much for answering my questions. Now I'm going to take some questions from the participants who are watching us,
Great.
if that's okay with you. We have
Yeah.
one from that says, Dear Suzanne, have you heard of Peter Wolleben and the book he wrote, The Hidden Life of Trees, of course? How do you see his work compared to yours?
That's a good question. Yeah, so I have never met Peter, but it's funny. A grad student of mine who's from Germany contacted me and said, "Hey, did you know Peter W. has written a book he says stuff like you do?" And I'm like, "No, I've never heard of him." And anyway, I was contacted by his publisher, the English publisher, who asked me to write a foreword for his book. And so I read the book, and yeah, I liked parts of it, and some parts of it I thought, but the benefit of Peter's book and books now are that he's able to speak to people and their hearts. And, I think he really raised awareness about forests in Europe, especially. And that's a gift. And even if some of the science is a bit wonky, well, you got to, there's a lot of good things in the book as well. My book is different in that it's really is based on my science, and it's my story as well. And he includes parts of my work in his Hidden Life of Trees, but I wanted to tell the whole story, right? Not just a little blurb about it. So, where did it come from? And why was it important to me to ask these questions? And what does it mean, in our forests in North America, which are very different than the ones he talks about. Yeah.
As a fellow scientist, I had that feeling too, like saying, just the way he used the language that trees care for each other and want to share things. And I've my eyebrows raised as a scientist, but then like you, he reached a lot of people. He sold a lot of books because of the heart, because we want to have a relationship with the forest and with the trees. And so it actually changed my writing a little bit too. In one of my books, I thought, well, I'll get more heart-centered as well.
I think, and I strive for that in my book too. I wanted people to read the book so that, like people love stories, right? Our minds are just like glom onto stories like Velcro. We love hearing stories. And so I thought, I'm going to tell stories of how my life unfolded and weave the science in, so that as people are reading the story and getting so attracted to the story, they're also learning almost seamlessly about the science. It's not an effort. And so then, when you learn and you can hook the science onto something that means something, personal or that human story, then you remember it more. And it's more interesting to read, I think.
Exactly right. Very effective. The story about going to see your brother in the rodeo and sitting by the side of the road with a knife and finding the truffles under there, the mycorrhizae. I could just picture that.
Yeah.
You're just so curious about the forest. Even on your lunch break, you're going to be poking around in the soil.
Yeah. And, one of the interesting chapters to me that I when I was thinking of starting this book, I really wanted to tell the story about being treed by the grizzlies. Like that was going to be I wanted that to be the opening chapter. And when I was writing it, my editor was saying, I think we should just delete that chapter because it doesn't really flow into the story, right? It's kind of stands out as you don't need it. And I was thinking, yes, we do need this story. And so then I put the science into it so that I could introduce, what the different kinds of mycorrhizas were as we were going up the mountain and getting treed by the bear, so that, you can't help but learn about the basics of mycorrhizas as you're reading that story. So then it ended up being an important part of the book. But that was a real learning experience for me in trying to get that in.
Great. Well, I have other questions here from the audience. We could go on all night. I'll give them a chance to have some questions answered. One of them, what do you think of certifications like FSC and SFI?
Yeah, I think that I think the intent of certification is good, that it gives people some kind of checkpoint to say, is this a sustainable forest product? I think FSC is better than what is the other one? SFI?
Yeah.
SFI. Because I was a little bit involved in the FSC development early on. not that I made that much influence, but the problem is that everything is certified now, right? It's like, how do consumers choose?
Yeah,
Like,
right.
it's become greenwashing in a way. And so, yeah, I like the idea if it was properly policed and regulated and that there were actual repercussions, like there were consequences for bad management. But it's like, it seems like, at least in Canada, well, I grew up in a province of old growth forest. It's now a province of clear cuts. And in the intervening period, everything was certified. So, to me, it didn't really work out.
Mhm.
Yeah, I don't know what you think, Joan.
Yeah. SFI, pretty useless industry standard. FSC, they were trying, they said, oh, let's do forestry better. But I've seen beautiful forests be clear cut that were certified FSC. So
Yeah.
it's not good enough. I'll put it that way.
It's
a
not good enough.
try, but it's not good enough yet. We had another question. Someone wants to know if you could address how forest trees both cooperate and compete with each other, right? So in forestry, it's thought always competition, but your research shows differently.
Yeah, I think that people, we kind of got trapped into thinking only about competition for quite a while. It's kind of a Western science outcome of separation of man from nature, that dominion over nature is important, competition is important. And of course, Darwin's natural selection theory is based on, for the most part, competition, even though he also understood the multiple ways that plants interacted with each other and evolved and adapted. But competition became the dominant theory for all kinds of cultural and even religious and even governmental reasons. And then it became adopted by industries, and then whole industries like the forest industry, the agriculture industries are based on managing competition. And in that fervor of doing that and trying to create these great big trees that we could sell and make money from, we forgot, I think we forgot that trees are complex creatures, just like we are, right? We communicate and interact in multiple ways. That's why we're so successful as a species. And trees are the same. They can compete and they can collaborate at the same time, no problem, right? A tree will shade out, its canopy can shade the understory, but at the same time be sharing resources through its root systems to support the survival of those trees. And that diversity is important to the fitness of that tree that's competing and collaborating at the same time. And so there's definitely a fitness element to this multiple ways of interaction and communicating with each other. They can walk and chew gum at the same time,
Right.
or they can stand still and chew gum at the same, or whatever. Yes,
That's great.
the analogy is not perfect, but yeah.
It reminded me of, when you have two canopies and they're growing near each other, there'll be a little space between them. And I've heard that called that, canopy shyness. And I'm thinking, oh, they're not doing this to be nice to each other. They're doing this because if they grow into each other, they'll be shaded, or their branches will break from the wind from bumping into each other.
Yeah. Actually, there was this study. I always think about this one study where I had a colleague at University of Alberta, and he had a student, actually, it was lodgepole pine forest, and he had them take 3 stands of lodgepole pine and he guy wired the crowns so they couldn't move for 5 years. And then he had a control forest where they were, allowed to sway back and forth. The crowns could abrade against each other. And when he had guy wired them so they couldn't move, that they had 30% more crown biomass after 5 years than the control forest where they were allowed to sway back and forth and abrade each other. So that crown shyness is, it is partly about just moving up and butting against each other and avoiding each other. And it's interesting how adaptable and plastic these forests really are.
The language. Let's see. I'm fascinated. This is somebody who's joining us says, I'm fascinated by the language of trees. Have scientists been able to identify differences in how trees communicate in healthy versus unhealthy forests? If so, can we use this information to help distressed forests and identify ones being stressed?
Mhm.
So,
Yeah, yes, they can. I mean, so I've done a bunch of experiments and other people have as well, where if we stress trees, they have a biochemical response. You know, they're physiological creatures. And if you pull off some needles or attack it with a herbivore or a pathogen, a bunch of pathways, biochemical pathways get triggered. And one of them is the jasmonic acid pathway. Another one is the salicylic acid pathway. Those are defense pathways. And they create a bunch of compounds that some of those end up being signals that are transmitted to neighboring trees through these mycorrhizal networks. And the neighboring trees will then detect these signals. And we found that they upregulate their defense genes. They make more defense enzymes, and that protects them against invasion of that thing that's actually, you know, caused the stress in the parent tree. And that's, so it's genetic, you know, it's an actual, like an epigenetic response. And then other studies have shown too that is actually transmitted into next generations. So the next generations of seedlings actually have that imprinted in their genes, and it improves their defense for, you know, for the next few generations. And so, yeah, I mean, it does make a difference. Like, they can tell. They're sophisticated. They're not standing there going, oh, I hope that nothing attacks me. They actually have agency in their own health.
that's the most fascinating thing, I think. People are just so used to looking at a tree and thinking it's this inert thing that's just stuck there and standing there. But you've showed us that they share and communicate in ways, they support each other.
Yeah, and I think, you know, another important part of that message too is that, you know, when trees are stressed or dying, or they, like, I think the fires in Oregon are a really good example. The trees, you know, they've been burned, and they might have died, or they might be dying. But in that dying process, there's a lot of processes going on, right? So one of the things that we found is that these old dying trees, they not only send information to their neighbors, they also transmit a lot of their carbon as they're passing on to, you know, right, directed through their networks into neighboring trees. It doesn't just get mineralized and go up into the atmosphere. There's a lot of work to be done by those old trees as they're passing. And, you know, in forestry, our zeal to make money, we go in and we try to chop them down right away, mill them, and make a buck, right? It happens in Canada all the time. It's the first response of human beings in the industry to do that. And I'm just like, hold on, you know, these trees still have a role to play in helping this ecosystem recover and passing on information to the next generations. And so I wish that we could stand back a little bit and just let these processes play out as they're meant to do.
And also, so much biodiversity depends on these older trees.
Yes, absolutely. Whole soil food webs, whole canopy food webs, like lichens and birds, and, you know, and small mammals and large mammals, they depend on that process to continue on. Yeah, you're absolutely right.
Forest, I was recently trying to save here in Maryland, where I am tonight. I spoke out against it, and the forest manager said, well, if we don't cut them down, they're just going to die. So we have to cut them down. It's like, wow. You know, the old trees, the dead trees are important for the forest. And so really that's when you say the mother tree and finding the mother tree with that title, could you talk about what that meant to you?
Yeah. So in this field of mycorrhizal networks, where, you know, it was controversial when I was starting out. And, you know, I always felt like I'd stepped into a hornet's nest, because we had the collaborative faction and the competition faction, and they were fighting each other. And I came along and said, oh, they're both happening at once. And that was like, oh, you can't say that. Or they would put me into one camp or another. Anyway, the field got stuck for a long time, and it was stuck in that. And it was also stuck in that, well, we can't see these mycorrhizal networks, so we don't really believe it, even though it was the scientists themselves who were, you know, had the best tools to see them and could see them with microscopes and DNA analysis and all that. But I felt like the whole field had been held back by this suspicion, right? And so I thought, okay, well, we need to do some basic things. We need to make a map of that network. And so I got a grad student with Kevin Byler, and we made a map of what the network looks like, and basically used the best DNA techniques we had at the time. And we showed that everything was connected to everything else, and that these biggest, oldest trees, the big old trees, were the most highly connected. They have the biggest root systems. They've got the biggest canopies, the most carbon going down into their roots and into these networks and supporting, the seedlings coming up underneath them. And they could even recognize their own kin, which is another amazing discovery we recently made. And so it was just like, okay, these old trees are nurturing the forest, the regeneration of the forest. And so that term mother tree, came from that, right? In graph theory, in neural networks, they're called hubs, these big nodes. And that's an easily forgettable word, but mother tree certainly isn't forgettable. People kind of immediately understand what that means. And so it's not really a scientific term, it's more of a human term, so that we can grasp, so that our brains could grasp that story better. That said, a lot of trees have mothers and fathers in them. I could have called them father trees. And in fact, in a lot of indigenous cultures, they have names in their own languages for mother trees, father trees, grandmother trees, grandfather trees. I mean, they've been recognized as being these big old trees important for millennia.
Yeah.
Yeah.
Wow, that research is so interesting. And I was called recently by someone from Hollywood. I think this was yesterday. Somebody was making a film for children, and they said, well, are these mycorrhizal networks in the eastern US forest too? And I said, well, I'm sure they are. Of course they are, although I haven't read the research. The research is all happening in other places.
So you're absolutely right, Joan. They are in those eastern forests. And there's been a lot of labs around the world who have studied networks in their own forest types, including in South America, North America, Europe, Asia, and they exist. It's a ubiquitous, it's a global phenomenon. And all trees all over the world require mycorrhizas to survive and be fit and to reproduce. And these networks, the fungi connect. They have this ubiquitous ability to connect trees together, and they can be either trees of the same species or even trees of different species. So yeah, it's a global phenomenon.
Universal. And we're just now learning about, when I give my talks, I put up that diagram you're talking about.
Okay,
with the mother tree and the hubs, and I talk about that and how recently it's been that we've known this. And I say, what else are we going to learn?
Yeah.
Right.
Right.
What else are we going to learn?
Yeah. And, it is a recent discovery using our tools, but that knowledge of connection has been known for thousands of years, right?
Yeah.
The indigenous people talk about connection, even fungal networks in the soil. They even, even mother trees. And so it's like, but they were ignored, right? Basically, that knowledge was ignored or even ridiculed or suppressed. And now, the Western science, it's a gift, it's a gift to bring back that knowledge. But also the important thing here, I think, is that there's so much indigenous knowledge that we've ignored. And maybe this is an avenue to open up that space for us to not think it as a bunch of fairy tales, that this is hard-earned scientific knowledge that's been through thousands of years of observation, and they know things that we don't know because we kind of West colonization was a transplant from Europe without knowing the land. And we took European methodologies and transplanted them to North America without knowing the variability, the nuances, those peculiarities of site. And I think I'm hopeful that this is a little window into that maybe there's a lot more here, that this is one little window. There's much more knowledge as well.
So maybe we're not learning these things now, maybe we're relearning them now.
We're relearning them.
Yeah.
And I think too, when people find out about this research, one of the most common comments I get from email or whatever is, I always knew this in my heart.
Yeah.
And it's because we are, we're we're just,
We're part of the network.
we're
too.
part of it. Yeah, we're just part of it. We're from it. We're made of this stuff.
And a question relates to that. Megan asks, how do you think we can get kids involved in understanding this interconnectivity of the forest ecosystem?
Kids are like the best, right? Like they're just like, of course that exists, right? Like I've taken kids from grade 1 out and just have them roll around in the forest, and they find the little networks, and there's all kinds of games you can play too, like making strings that connect everything together, and you pull on one string and something else moves over here. It's they gravitate to it. It's a natural for them, you know. I don't know. I think that it's easy to do that. And I think that getting the kids outside is really super important, instead of having them always, you know, always sitting in a little desk in the classroom and just, you know, we need to allow them. We really have they've got to have the opportunity to connect with their roots, with nature.
Yes.
Yeah.
Yeah. That's part of what my work is, trying to let people know where those forests are, that they can bring the children to build a relationship, to be the next generation.
Right.
To be doing
Super
that.
important. It's super important to have your heart connected to the forest.
Thank you.
Or whatever ecosystem you're in. Yeah.
Another question is from Ward. I learned about you from reading the Overstory. How does it feel to become a fictional character? Do people think you are Patricia?
Well, I'll ask you that, Joan, because you and I are both Patricia. It feels pretty cool. I think it's cool.
Yeah.
I think he did a wonderful job, and I think that character is really interesting and complex, and it reflects some of the reality of what it's like to be a female scientist. What do you think?
Yeah, I think he did do a great job, because he obviously had to understand the connections to be able to write that character and what she was seeing and doing. But I would like to have somebody bring me lunch every day from wild crafted food. That hasn't happened in my life. But yeah, Richard Powers did an excellent job with that book, and
he did,
honoring your work. So.
It's a great book. I mean, it's so complex, and also just making people aware of, you know, what's going on in the redwoods and what's going on in the Douglas fir, what's going on in our forests, right? Wow, I think most people don't have time, or, you know, or it's hidden from us. It's so hidden in Canada. You know, there's all these, you know, visual quality rules so that you hide the clear cuts from the public view. And so you're driving along a corridor and you think, oh, it's all great, but over the hilltop, it's just like clear cut after clear cut. And I think that his book really, you know, brought that home, that it helps people sort of see it through storytelling.
And also the character that was planting all those trees, thinking he was doing such a great job planting the trees. And so many people are into planting trees, and I say, that's fine, but are these trees going to be allowed to grow for a full life?
Yeah. And I think, you know, and you're right, like there's lots of talk right now of planting 1 trillion trees, and I think that's great, but we can't get distracted from saving our old growth forests. This is not a reason to cut down forests so that we can plant our 1 trillion trees, because we lose far more by cutting down forests than planting. And the planting, I mean, it's important for reforesting and afforesting, or restoring damaged ecosystems, but it's not a replacement for these magical, or these incredible, you know, these incredible ecosystems that are our life support systems.
Well, I think that's a beautiful place to stop. And I just so appreciated being able to have this conversation with you.
Likewise.
And I can tell, you know, as female scientists and advocates for the forest, that we're part of that. We're connected.
Comrades in arms. Yes.
Yeah, and we welcome everybody listening to join us.
Yes, please do. Please
visit the forest, get involved in the Mother Tree Project, read this wonderful book.
Get involved in the Old Growth Network as well.
Thank you, Suzanne.
Okay, thank you very much, Joan. It's been so nice talking to you.
Thanks.